All right, good morning, everyone. This is Melody Rondo, and I'm going to be talking through our lesson on finding the volume of a sphere. We have our essential question that's listed there. How do you find the volume of a sphere? And our learning targets, there are two. The first one, I can use the volume formula for a sphere to solve problems. Our second one, I can use volume formulas to solve problems with composite shapes. For your notes today, you should have your notes packet, and you guys can go ahead and just make sure to copy down the first of those two learning targets. Although we are covering both of them, our main focus is on the first one. All right, so if you will turn to the back page in your packet to the volume and area formulas, find our last box that has this picture in it, and go ahead and title it Volume of a Sphere. And then we are going to fill in our volume formula, which looks like this: V equals 4/3 pi r cubed, where V, of course, stands for volume. Pi, of course, is going to be the pi button on our calculator. Sometimes we do represent it or use 3.14 to approximate it, but we'll mostly use our pi button. And then R for radius, of course. And in our picture here, of course, the radius that we're talking about is from the center to the outer edge. It is the radius of this circle that is sometimes called a great circle. It's kind of like if I sliced the sphere, which is kind of like a ball or like a globe. If I sliced it, I would see a circle, and that circle like being in the middle. So it's the great circle because it's the largest circle within the sphere. Anyways, we want the radius of that one. So as long as it is marked with a big dot like that as the center, you have a line to the outside, then you have your radius. All right, let's go forward. Example 1. A spherical water tank has a diameter of 27 meters. How much water can the tank hold? Round to the nearest cubic meter. Remember, if it says nearest cubic meter, if it gives you a unit, that is asking for a whole number. So when we round, we want a whole number. All right, and then we're asked how much water it can hold. That is volume. Volume is the area or the space that is taken up. They tell us the diameter is 27 meters, and that notation should look a little bit familiar to you. We talked about when you point to the center, that's our way of saying that it is the diameter. But of course, I'm going to need to know the radius. So my diameter is 27. The radius, you may recall, we take that 27 and we're going to divide it by 2. I get 13.5 meters for my radius. All right, then I'm ready to use my formula, that brand new formula. Volume equals 4/3 pi r cubed. I have my radius. I'm ready to go. So here goes. Volume equals 4/3 pi. My radius is 13.5, and that's going to be cubed. To help us out today, I am going to include using Desmos. So we're going to pop over. Oh, that's precious. Yes, I know my thing is recording. Can make that go away. Okay, cool. Sorry about that. All right. I'm going to pop over to Desmos here. So here's Desmos. I'm using the scientific calculator. And so I'm going to type in those numbers. I had 4/3, which, remember, you can do 4 divided by 3, or you can use the fraction button over here on the right. So I'm going to do 4/3, and that is times pi, so my pi button, times the radius cubed. So my radius was 13.5. And to do the cubed, we used the squared before. The cubed, you can use that and then delete the 2. So I'll show you what that looks like this. And then delete it and turn it into a 3. That, I know a lot of students do that. You can also do the other button, A to the B. Instead of the squared, if you do this one, you just type a 3. And it's set to go. It looks like 10,305.9947. So let's pop back over to our presentation here, and we will talk about how we're rounding it. So that number again was 10,305.9947. 9947, and it would probably continue on and on. We're rounding to the nearest cubic meter, which means whole number. That means no decimals. That's my cutoff line. I look back, and the 9 tells me to round up. So I would have 10,306. My unit is meters, and because we're finding volume, it is cubed, and we actually can see the cubed in the radius step there. All right, that's example 1. Let's go on to example 2. Find the volume of the composite figure, round to the nearest cubic centimeter. So nearest cubic centimeter, again, if we're asked for a specific unit, this is also asking us for a whole number, which is a little different than what we normally do. We normally do the nearest tenth, but this is good practice for us to try a different number. So awesome. All right. Looking at my figure, I have some shapes here. I have what looks like a sphere, but it's not a whole sphere. It's actually a half sphere. I'm going to write it that way as half a sphere, but it does have a name, kind of like half a globe. We call it a hemisphere. But for our purposes here, I'm going to remind us that it is half a sphere, but the actual name is hemisphere. And we're going to be adding to it, because we have that's just part of it. The other part would be a cone. And so let's see what we can do here. So half of a sphere, I'm going to start with half, and then I'm going to do the entire sphere formula, which is, actually, I'm not going to do half. I will do that in a minute, actually at the end. Okay, sorry. Let's start with the sphere formula. We're going to do 4/3, and then it is pi r cubed. So my volume here, 4/3 pi. Do we know the radius? Yes, we do. It is 5. There's my radius, 5 centimeters. So I have 5 cubed. And now when I calculate this, this is going to give me the whole sphere. But if I want to find half of it, so basically a half sphere, I can take the answer and divide it by 2, or I can say half of this value. So like I started to do, I could sneak in a 1/2 of the sphere formula in this way. So that's kind of a cheater way to do it because my equation doesn't look consistent, but it works. I am doing half of it, or take this answer and divide by 2. I'll show us both to prove it to you. Let's take a look at Desmos. So let me pop that in again. All right, so we need, one version is to do half. So I'm going to do 1/2. And then I have times the fraction 4/3 times, my next thing was pi, and then my radius 5⁻⁻. So I get 261.799, blah, blah, blah. Okay, so that's one way. But if you don't like the 1/2 version and you want to just find this answer, you can find this answer, hit enter, and then say divided by 2. Oopsie, not that way, sorry. Say answer, which is going to pop in our previous answer, and then say divided by 2. And you can see we still get 261.799, whatever. So it's up to you if you want to do 1/2 times the value, or if you want to take the value of the sphere and then divide it by 2. That either way, your choice, but we are looking at 261.799, blah, blah, blah. So I'm going to go back to our presentation. And again, that number was 261.799. I think it was a 3. ... of course. And we are rounding to the nearest centimeter, cubic centimeter, which means whole number. So I look back and the 7 tells me to round up. So I get the volume as a rounded value. So I'd say approximately 262. And of course, this is cubic centimeters, or centimeters cubed. All right, then I need the cone. If you review, back in the back of your notes packet is that formula page. The volume of a cone is 1/3 the area of the base times the height. So I'm going to go, okay, 1/3 the area of the base. The base of a cone is a circle. So my area formula is going to be the area of a circle, pi r squared. Cool. And then times the height. Then I'm going to keep going. Let's see, I have 1/3. I know what pi is. My radius is 5. But here's where I run into an issue. I don't know the height of the cone. Now, I do happen to have radius, and then my height would be this value right here. There's the height of my cone. And we talked about the fact that the radius and the height always have a 90-degree angle. So with my radius and my height, I actually have a right triangle, including that slant height there of 13. So I can use Pythagorean theorem. Of course, if you happen to recognize these numbers from last unit, we talked about Pythagorean triples, that one of our special sets of numbers that always works in Pythagorean theorem is 3, 4, 5. This is not that triangle. But another one is 5, 12, 13. So if you happen to know that, you could immediately say, oh, the height is 12. If you don't know that, which we're going to pretend we don't, we are going to do Pythagorean theorem to prove it. Remember, a squared plus b squared plus c squared, equals c squared. In that formula, the one that we need to make sure we get in the right place is the c squared, or the hypotenuse, which is our slant height. So I'm going to make sure 13 is my c. The other two, I can fill them in however I want. I'm going to do 5 squared plus h squared. And I'm going to solve for h squared. So let's see what we get. 25 plus h squared equals 169. Subtract 25 from both sides. And we get, let's see, that cancels. H squared equals 144. Square root to get rid of the squared. And I get h equals the square root of 144 is 12. So there we see that same answer of 12. And I'm going to tag on centimeters up here. 12 centimeters for the height. I fill that into my equation. And then I am ready to go use the calculator. So let's pop back over to Desmos. Desmos, here we go. All right, and so I'm going to get rid of these lovelies. I don't want all this extra stuff. Cool. All right, so popping that one in here, I have 1/3, and I am doing times pi times 5 squared, and then times the height, which we found was 12. I get 314.15926, blah, blah, blah. Perfect. All right, back to our presentation. Okay, so that number again was 314.159, blah, blah, blah. We are rounding to the nearest centimeter or whole number. So that means I don't want any of these decimals, but I look back at the one. The one tells me to round down or stay where I'm at. So I would say V equals, or is approximately rather, since we rounded, is well, that's not a very good approximate. One more time. Whoa. Is approximately 314 centimeters cubed. Our final step back at the top, we did say we were going to be adding those together. So adding them together, I have 262 plus 314. When I add them together, I get, let's see, 576. So I have a volume of 576 centimeters cubed. And that finishes our notes for today. You guys have a practice, I believe, in Delta Math. Check it out in Google Classroom. And thanks so much. Adios.